Alright. So, what we start with is the Mother function for natural logs. And unlike regular logs where it changes based upon the base, natural log is always the same base. Alright? So the values that we want are e to the negative 1, 1, and e. Because when we plug those in, we can get rational values. Now, 1 is going to stay exactly the same. E we're going to estimate to be 2.7 because as you know, when you do these next Thursday, you will do part of it without a graphing calculator. And then e to the negative 1 is approximately 0.4 or 0.4. That will give us the same thing it gave us for logs. In other words, the 1 gave us 0, e or 2.7 gave us 1, and 0.4 gave us negative 1. All right. We would then graph that. .4, negative 1 would be about here. 1, 0. Our x-intercept would be there. And then 2.71 would be about there. And then there's the shape of our graph, just like all other log graphs. X equals 0 is our asymptote. Everything is to the right of that, so our domain would be x is greater than 0. Our range, just like other logs, is all real numbers. The x-intercept, if you have it in your data points, it will be asked of you, so 1, 0. If it's not, it will not be asked of you. And then as x approaches infinity, just like with other logs, f of x also approaches infinity. It increases. So that is the mother function everything is based upon. Alright, so if we flip it over and start with number 1, the natural log of x minus 1 minus 5. First thing you should notice, just like with logs, you see parentheses. That is your horizontal shift. And that is the opposite. And then when you have the number outside, that is your vertical shift. That means when we create our table of values, we have to do the opposite of negative 1, which is plus 1 to all of our x's. So instead of 0.4, we're going to start at 1.4. Instead of 1, we're going to go to 2. And instead of 2.7, we're going to have 3.7. So that's our x's. We just do the opposite of whatever's inside parentheses, provided there's no coefficient, which we'll talk about in a second. Then you take your y's and you apply the vertical shift. So what was originally a negative 1 will be negative 1 minus 5, which is negative 6. Which was originally 0 would be 0 minus 5, which is negative 5. And what was originally 1 will be 1 minus 5, negative 4. We're then going to plot those points, 1.4, negative 6. 2, negative 5. 3.7, negative 4. The opposite of the parentheses is your asymptote. So the opposite of negative 1 is 1. So that will be beneficial in terms of creating your curve. And that will enable you to do that. And then you would fill in your table of values just like you did with logs. Domain x is greater than 1. Range all real numbers, increasing. Because there is a vertical shift, You would not be asked to find your x-intercept. All right. Number 2, we're going to change up a little bit. Instead of x plus 5, we're just going to call it negative x. So y equals the natural log of negative x inside parentheses minus 5. As we discussed yesterday with logs, when it's inside parentheses, it affects your x's. So instead of 0.4, that would be negative 0.4. Instead of positive 1, this would be negative 1. And instead of 2.7, it would be negative 2.7. And then again, if we have a negative 5 on the outside, that's our vertical shift, which would affect your y values. So just like in the last one, we'd have negative 6, negative 5, and negative 4. Since there is no number being added and subtracted to x, our asymptote goes back to being the y-axis, better known as x equals 0 in some parts. If I then plot those points, negative 0.4, negative 6, about there, negative 1, negative 5, approximately there, and negative 2.7, negative 4 is about here. You then use those points as well as the asymptote to create your graph. And then you fill in the information. The domain, instead of x greater than, domain now would be less than, in this case 0. Your range is all real numbers. Instead of increasing, that one is decreasing. And because you have a vertical shift, I would not expect you to come up with the intercept. All right, number 3, we're going to get rid of the plus 4, and we're going to put the negative on the outside. So now we got y equals the negative natural log of x plus 5. When the negative is on the left-hand side of either log or natural log, it doesn't affect your x's, it affects your y's. So, I have a plus 5 inside parentheses, which tells me I have a horizontal shift equal to negative 5. So I would subtract 5 from all of my values. 0.4 minus 5 is negative 4.6. 1 minus 5 is negative 4. 2.7 minus 5 is negative 2.3. Because I have no vertical shift, that allows me simply to put negative 1, 0, and 1 to start. And then if you have a negative on the outside, that means you flip all the signs of your y. So that means instead of a negative 1, that would switch to a positive 1. 0 is always going to be 0 no matter how hard you try and change it. And the positive 1 goes to negative 1. Negative 4.6 and 1 is going to be about there. Negative 4, 0 is going to dip down a little bit. Negative 2.3, negative 1, probably around there. The opposite of positive 5 is negative 5. So that means x equals negative 5 is your asymptote. Again, it's going to be extremely beneficial for you to include that so you get the shape of your graph. That way you can draw correctly. Everything is to the right of it. So basically, x, the domain would be greater than negative 5. Range all real numbers. Now, your intercept is one of your data points. Negative 4 is 0, so I would expect you to be able to answer that. After we get through solving equations, then we can go back and talk about intercepts when you don't have it necessarily. All right? And then it is decreasing as you move to the right. And then the last problem of the day, we are going to change this to the natural log of 2x minus 3, and we're going to keep the negative 4. So we're going to give the coefficient. All right? Again, I would tell you, just like logs, you take whatever's inside parentheses and set it equal to 3 values. The middle value is still the same, 1. The difference is we're not setting it equal to the base and 1 over the base. Well, we are, but that base is e and 1 over e. So we would set it equal to 2.7, since that's e to the 1, and 0.4, because that's e to the negative 1. And then solve each. For the top one, if I add 3, I get 3.4. If I divide by 2, I get 1.7. For the middle one, if I add 3, I have 4. If I divide by 4, I have 2. And if I add the 3 to 2.7 and divide the 2.7 by 2, I get about 2.85. Again, you'll have one of these for Thursday, so you can do addition, subtraction, multiplication. All right? The negative 4 affects your y, so instead of negative 1, 0, and 1, I'm going to subtract 4 from each of those, so negative 5, negative 4, negative 3. You're then left to plot those points. 1.7, negative 5 is there. 2, negative 4 is here. 2.85, negative 3 is probably around there. And just like with logs, you need to get your asymptote. To get your asymptote, you set whatever's inside parentheses equal to 0. You solve for x, you get 1.5. That, my friends, is your vertical asymptote. That allows you to realize that your graph's going to look something like that. And then you fill in all the information from there. Domain, x is greater than the 1.5 or 3/2. The range, all real numbers. There's a vertical shift, so don't worry about the asymptote. All right, and then it is increasing as it moves.